How can I write and graph linear equations using slope-intercept form and point-slope form? Couple things to quickly go over. A linear equation is an equation that represents a straight line on a graph. So if I were to graph it, it would create just a single straight line. Y-intercept would be, that's going to, when we talk about like intercept, like slope-intercept form, that's going to be where the graph would cross the y-axis and or where x is going to equal 0. The x-intercept is where the y ends up equaling 0. We'll cross the x-intercept. For the purpose of this, we'll be focusing on the y-intercept, and we'll just call it the intercept. So slope-intercept form, hopefully you've seen this before. It's generally referred to where y equals mx plus b, where m is the slope and b is the y-intercept, aka where x equals 0. I would use this form in, say, this example, y equals 4x minus 3, where I would say, okay, if x is 0, 0 times 4 is 0, 0 minus 3 is negative 3. So I can fill in this chart where x is 0, y would be negative 3. If x is now I can go ahead and fill in the rest of these. These are going to give me ordered pairs where x is negative 3. Negative 3 times 4 is negative 12. Minus 3 is negative 15. X is negative 1. So negative 1 times 4 is negative 5. Negative 5 minus 3 is negative 8. 2, positive 2. 2 times 4 is 8. Minus 3 is 5, positive 5. So now I have these coordinates or ordered pairs where I can say negative 3, negative 15. I can now create a graph. 1, 2, 3, and then I go down to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I thought I counted this already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yeah. So negative 3 and 15 would generally be about here. It's not going to be perfect. I'm not using graph paper. Negative 1, negative 8. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8. 1, let me count that again. 1, 2, 3, 4, 5, 6, 7, 8. So it'd be right about here. 0, negative 3, 0, 1, 2, 3. And again, that's your intercept, which is why this here is going to be the, oops, I went the wrong way. 1, 2, 3, sorry. I plotted that point wrong because it should be plus b. So since it's a subtraction, that means it's actually negative 3. So my y-intercept would be down there, not here. And then 2, 5. 1, 2, 1, 2, 3, 4, 5. So be careful with your signs. Plus b, so b would be there. And now I have these 4 points. I can use like a straight edge or something, like my other slide here. If I had graph paper, it would definitely prove out to be a straight line. But since I don't, it's not going to be quite perfect. That's their slope-intercept form. Okay. Point-slope form. This should be new. I'm going to show you 2 ways to play a little game where we kind of come up with this. So you should try to play this game as well. All you need is 1 die. You could use 2 dice if you want to have an added challenge, but just to make it simple. And I took them directly from a game. So just find a board game. Dice. So I roll it 3 times for the level 1. My first one is 2. My second roll, I know it's off camera, so you're going to have to trust me, is 5. All right, so that's going to give me a coordinate, 2, 5. That's my point. And my third one is 6. And 6 is going to give me my slope. So that's level 1. I get a point and a slope. So to do that, I can substitute in here where I do y minus y sub 1, which would actually be 5. So I would substitute in here. So I do y minus 5 equals my slope of 6 times x minus 2. And I can take that and I can create a chart. I can use algebraic properties to create the the slope-intercept form where I could then, again, create a table of values. You could substitute in values here for this and end up creating a graph. I will show you how to get this to slope-intercept form, from which point you could rewind the video and look at how to graph from slope-intercept form and create the table. So to get this to slope-intercept form, where it's like y equals mx plus b, you could say, okay, y minus 5, so let's get y by itself. So let's do plus 5 to both sides. And then you have y equals, and I can distribute this 6. So I can do 6x minus 6 times 2 is 12 plus 5. So y would equal 6x minus 12 plus 5, which would be negative 12 plus 5 would be negative 7. So I could say minus 7. Now I could also create a quick graph of this way by saying, okay, here's my y, 1, 2, 3, 4, 5, 6, 7. So here's my y-intercept. My slope is 6. That means rise over run. So I go up 6 over 1. 1, 2, 3, 4, 5, 6 over 1. So that would be another coordinate on this. And this would be the line. That would be represented by y minus 5 equals 6 times x minus 2. Again, if you have a point and a slope. Level 2 of this game is an added challenge. You're going to roll 4 times to get 2 coordinates. So my first roll would be the first x coordinate, 1. My second roll is a 5. My third roll is not going to be the slope. Instead, it's going to be another x coordinate, 6. And my next one is going to be 6. You could actually graph this at this point. I could do 1, 5, 1, 1, 2, 3, 4, 5, and 6, 6. So 1, 2, 3, 4, 5, 6. Up 6 would be here. And I can create this, which is a rough sketch of the line. Now, how do I create the point slope form? We have to actually calculate your slope. So you would use the slope formula of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So x2 is going to be 6 and 6 because they're both 6 here. So 6 minus 5 over 6 minus 1. So the slope's going to equal 6 minus 5 is going to be 1. 6 minus 1 is going to be 5. So my slope is 1/5. Now I can use either one of the points to substitute into my point slope formula. Here I'm going to kind of erase some to give myself some more space to work. So my slope is 1/5. Change colors just so you can see this work here. Y minus 5 equals 1/5 times x minus 1. I can obviously turn this into slope-intercept form and go through that process, but this would be the point slope form of this equation. And you can just use the dice. You can do level 1 and level 2 to practice kind of writing this, graphing it, and everything in between.